Hey everyone, in this video what we're going to do is we're going to evaluate the limit as x approaches 2 of x squared plus 2x minus 8 divided by the absolute value or modulus of x minus 2. We're going to begin by factoring the numerator. So we have x squared plus 2x minus 8. Now we need two numbers that multiply together to give minus 8 and add together to give 2. 2 and 4 are prime candidates. If we multiply 2 and 4 we get 8, but we have minus 8 here, so we know that one of these is negative, right? We need to be able to add these two numbers together to get 2, so that should tell us that we have minus 2 and 4. That means we can rewrite our numerator as x minus 2 multiplied by x plus 4. So we now have the limit as x approaches 2 of x minus 2 multiplied by x plus 4 divided by the absolute value of x minus 2. Now at this point you might want to just say that x minus 2 divided by the absolute value of x minus 2 is equal to 1, but this is not the case. And to see this, what we need to do is we need to look at the definition of the absolute value function. We have the absolute value of x is equal to x if x is greater than or equal to 0 and minus x if x is less than 0. So how do you think we can rewrite the absolute value function for x minus 2? Well, if we have the absolute value of x minus 2, using our definition above, we get x minus 2 if x is greater than or equal to 2, because that would give us 0, and we get minus x minus 2 all in brackets if x is less than 2. So we can see that the absolute value of x minus 2 takes on different values when approaching from the left or right. So what we need to do is we need to evaluate our limit as x approaches 2 from the left and as x approaches 2 from the right. So we have the limit as x approaches 2 from the right of x minus 2 multiplied by x plus 4 divided by the absolute value of x minus 2. Now, using our definition here for the absolute value of x minus 2, we can see that if x approaches 2 from the right, that x is greater than or equal to 2. So we can rewrite this as the limit as x approaches 2 from the right of x minus 2 multiplied by x plus 4 divided by x minus 2. These two cancel, and we're just left with the limit as x approaches 2 from the right of x plus 4. And if we let x be equal to 2, we get an answer of 6. Now let's look at what happens if we approach 2 from the left. We have the limit as x approaches 2 from the left of x minus 2 multiplied by x plus 4 divided by the absolute value of x minus 2. Again, looking at our definition right here, we see that for values of x less than 2, the absolute value of x minus 2 is equal to minus x minus 2. So we have the limit as x approaches 2 from the left of x minus 2 multiplied by x plus 4 divided by minus x minus 2. Now x minus 2 divided by minus x minus 2 is equal to minus 1. So we have the limit as x approaches 2 from the left of minus x plus 4. And if we let x be equal to 2, we get minus 6. So we can see that the limit as x approaches 2 from the right and from the left do not equal each other. What does this tell us? It tells us that our limit does not exist, right? Because the limit as x approaches 2 from the left doesn't equal the limit as x approaches 2 from the right. And that's the final answer to our problem. Thank you very much for watching. If you found this content useful, make sure to like and subscribe. I hope you have a great day.